Hi, my name is Manusha, Assistant Professor in Mechanical Department. Today I am going to discuss about shape function for a four-noded quadrilateral element in finite element method subject. Okay. So this is a shape function for a four-noded quadrilateral element. So for deriving the quadrilateral element derivation, first we have to take the x and y axis. Okay, this is the x axis and this is the y axis. So we are deriving for quadrilateral element. So for deriving the quadrilateral element, we have to draw the quadrilateral diagram. Okay, this is the quadrilateral diagram. This is the node 1 and this is the node 2, this is the node 3 and this one is the node 4. So every node is having the x and y directions, means nothing but every node is having the u1 and v1 displacements. So for node 1, u1 and v1, and for node 2, u2 and v2, and for node 3, u3 and v3. So similar for node 4, u4 and v4. So these are the four nodes. Every node is having the 2 degree of freedom. 2 degree of freedom means nothing but x and y directions. So x and y directions means for x axis we are taking as u1 as displacement, and for y axis we are taking v1 as displacement. Okay, this is the 2 degree of the freedom. Every node is having the 2 degree of the freedom. So for deriving the shape function equation, already we know that u is equal to n1 u1 plus n2 u2 plus n3 u3 plus n4 u4. This is the x axis. Similarly, for y axis we are taking as displacement as v. So for v, n1 v1 plus n2 v2 plus n3 v3 plus n4 v4. These are the shape function equation. Finally, we get this shape function equation in matrix form. So now we have to derive this shape function equation. We are taking as polynomial coefficient equation. From polynomial equation, u is equal to a1 plus a2 into xi plus a3 into eta plus a4 into xi eta. This is the polynomial coefficient equation. In this polynomial coefficient equation, we taken as xi and eta are the coefficients for this polynomial equation. So we substitute this xi and eta in this polynomial coefficient equations. This is the equation number 1 and this is the equation number 2 and this is the equation number 3. Similarly, for y axis, a5 plus a6 into xi plus a7 into eta plus a8 into xi eta. This is the fourth equations. Okay. So for deriving this quadrilateral element, we are taking as rectangular elemental coordinatal equation. So this is x and y. This is the rectangular element. So for this rectangular element, we are taking coordinates. First we are represent nodes 1, 2, 3 and 4. For these 4 coordinates, for these 4 nodes, we are taking the coordinates. X direction. X direction means this one x and this one y. X direction is taken as negative and y direction downwards negative. So minus 1. Similarly for node 2, x axis positive direction, so plus 1. Y axis negative direction minus 1. And for node 3, x axis positive 1 and negative y axis also here positive. And for node 2, x axis negative direction and y axis upward direction, so 1. So this is a plus 1. Okay, these are the 4 coordinates for rectangular element. These 4 coordinates have to substitute this in this third equation. Okay, from first coordinate element minus 1 comma minus 1. So for this coordinate we are taking the u as u1. So for node 1, u is equal to u1 for node 1. So u is equal to u1 comma, and we are taking as coefficients xi comma eta. Xi comma eta, and these coordinates are minus 1 comma minus 1. Now these coordinates equations will be substitute in this third equation. So we are taking u is equal to u1. So here u is there. So here u1, that is equal to a1 plus a2 into xi. Xi means -1 plus a3 into eta. Eta means here also -1 plus a4 into xi into eta. Xi into eta means -1 into -1. So u1 is equal to a1. So -1 into a2 minus a2 -1 into a3 minus a3 plus a4 into -1 into -1 plus 1. So plus a4. This is the u1 equation. This will be here up to fourth equation. This is the fifth equation. Now substitute another coordinates for node 2. For node 2 we are taking as 1 comma -1. Okay. So for node 2 u is equal to u2. That represents xi comma eta. Xi comma eta values are 1 comma -1. Now substitute again these coordinate equations, coordinates in this third equation. So u is equal to u2. That is equal to a1 plus a2 into xi. Xi means +1 plus a3 into eta. Eta value -1 plus a4 into xi eta. So 1 into -1. So u2 is equal to a1 plus a2 -1 into a3 minus a3, 1 into -1 -1 into a4 minus a4. This is the equation number 6. Now 2 nodes are remaining. So for node 3, u is equal to u3. So u is equal to u3. So here u means u3 is equal to a1 plus a2 into xi. So for node 3, what are the coefficients? 1 comma 1 are the coefficients. That means coordinates. So a2 into xi means 1 plus a3 into eta plus a4 into xi into eta means 1 into 1. So u3 is equal to a1 plus a2 plus a3 plus a4. So this is the equation number 7. Now again for node 4. For node 4, u is equal to u4. So u4 means coordinates are -1 comma +1. Yes. So for node 4, u is equal to u4. So u4 is equal to a1 plus a2 into xi. Xi means -1 plus a3 into eta means +1 plus a4 into xi eta -1 into 1. So u4 is equal to a1 plus a2 into -1 means -a2 plus a3 -1 into +1 minus a4. This is the equation number 8. Now we get polynomial coefficient equation a1 plus a2 plus a3 plus a4. So we have to find out this a1, a2, a3, a4 coefficient equations. So finding the a1, a2, a3, a4 equations, we have to add this 5 and 6. Again we have to add this 7 and 8. Now add 5 and 6. So fifth equation, u1 is equal to a1 minus a2 minus a3 plus a4. Again sixth equation, u2 is equal to a1 plus a2 minus a3 minus a4. So we are adding these two equations. We are adding these two equations means u1 plus u2, that is equal to a1 plus a1 2a1 minus a2 plus a2 cancel, minus a3 minus 2a3, again plus a4 minus a4 both cancel. So this is the equation number 9. Okay, now add. So 5 and 6 we add. Next again 7 and 8. Now add 7 plus 8 equations. U3 is equal to A1 plus A2 plus A3 plus A4. Again 8th equation, U4 is equal to A1 minus A2 plus A3 minus A4. Now U3 plus U4 is equal to A1 plus A1, 2A1 plus A2 minus A2 cancel, plus A3 plus A3 plus 2A3 plus A4 minus A4 cancel. This is the equation number 10. Okay. Now from this equation we get two polynomial coefficients. Okay. So these are the 9th equation and 10th equation. So again we have to add 9 plus 10 equations. So here u1 plus u2 plus u3 plus u4 is equal to adding. So 2a1 plus 2a1 is equal to 4a1. Next minus 2a3 plus 2a3 cancel. So from this a1 is equal to, so this 4 come this side means 1 by 4 into u1 plus u2 plus u3 plus u4. Okay, this is the a1 coefficient equation by adding this 9 and 10. This is the 11th equation. Again we have to subtract by subtracting 9 minus 10. So these two equations have to subtract again. U1 plus U2 is equal to 2a1 minus 2a3. Again U3 plus U4 is equal to 2a1 plus 2a3. Now we have to subtract these two equations. Two equations have to subtract means here plus u3. Plus means we have to take minus. Plus u4. That means minus. Again plus 2a1. That means we have to take minus. Plus 2a3 means we have to take minus. Because we are subtracting these 9 and 10 equations. Now write the equation u1 plus u2 minus u3 minus u4 is equal to plus 2a1 minus 2a1 cancel. Next minus 2a3 means minus 4a3. So a3 is equal to minus 1 by 4 into u1 plus u2 minus u3 minus u4. So finally a3 is equal to 1 by 4 into, here minus is there. So minus term we have to write into the equation. So minus u1 minus u2 minus into minus plus u3, next minus into minus plus u4. So this is the a3 coefficient equation. This is the equation number 12. So we get, by adding 9 and 10 and subtracting 9 and 10, we get a1 and a3 coefficients. For getting a2 and a4 coefficients, again we have to do the same procedure like 5 and 6 equations have to subtract, and again 7 and 8 equations have to subtract, so that we get a2 and a4 equations. So those polynomial equations have to substitute in the polynomial coefficient equation, so that we get the shape function equation. Okay, now we have to subtract this 5 and 6 equations. So now we are subtracting. So here plus u2 is there. So it is minus, and plus a1 means minus, plus a2. So minus a3 means this is a plus term, minus a4 means this is a plus term. So subtracting means u1 minus u2 is equal to plus a1 minus a1 cancel, minus a2 minus 2a2 minus a3 plus a3 cancel, plus a4 means plus 2a4. Okay, this is u1 minus u2. Next, subtract 7 and 8. 7 minus 8. So 7th equation is u3 is equal to a1 plus a2 plus a3 plus a4. Next, u4 is equal to a1 minus a2 plus a3 minus a4. Now we are subtracting these 7 and 8. So plus u4 means minus u4, plus a1 means minus a1, minus a2 means plus, plus means minus became minus means plus a4. So u3 minus u4 is equal to plus a1 minus a1 cancel, plus a2 plus a2 2a2, plus a3 minus a3 cancel, plus a4 plus a4 plus 2a4. This is the another equation. So this is the 12th equation. This is the 13 and this is the 14. Now getting the remaining terms, we have to subtract an addition of these terms. Now add u1 minus u2 is equal to minus 2a1 plus 2a4. u3 minus u4 is equal to 2a2 plus 2a4. So now we are adding the equations. So u1 minus u2 plus u3 minus u4 is equal to minus 2a1. This is a minus 2a2. Okay, minus 2a2 plus 2a2 cancel. Plus 2a4 plus 2a4, 4a4. So from this we are getting the a4 polynomial coefficient equation. 1 by 4 into u1 minus u2 plus u3 minus u4. This is the a4 coefficient equation. Okay. So for getting another coefficient equation, we have to subtract these two equations 13 and 14. u1 minus u2 is equal to minus 2a1 2a2 plus 2a4. u3 minus u4 is equal to 2a2 plus 2a4. Now we have to subtract. Here minus plus u3 means taken as minus, minus u4 means plus, plus 2a2 means minus, plus 2a4 means minus. So we have to subtract these equations u1 minus u2 minus u3 plus u4 is equal to minus 2a2 minus 2a2 minus 4a2. So plus 2a4 minus 2a4 cancel. So from this a2 is equal to minus 1 by 4 into u1 minus u2 minus u3 plus u4. So a2 is equal to 1 by taking minus into equation minus u1 plus u2 plus u3 minus u4. This is the final coefficient equation of a2. Now we have to substitute a1, a2 and a3 and a4, these four coefficient equations in polynomial equation. So this is the polynomial equation. U is equal to a1 plus a2 into xi plus a3 into eta plus a4 into xi eta. Substitute those a1, a2, a3, a4 coefficients in this polynomial equations. So already you have to substitute like this. Now we have to multiply these terms. So this is the xi eta and xi eta. So here already u1, u2, u3, u4 all common terms. So 1 by 4 into, first we have to common the term u1 plus 1 by 4 into u2 term plus 1 by 4 into u3 plus 1 by 4 into u4. Okay. So 1 by 4, first u1 term we are taking as common. So here u1 term is here plus u1. So plus u1 means here multiply any term is not there. So here u1 already taking as common as 1. Again next equation. So here xi is there. So xi into minus u1. Here already u1 taken as common. So minus u1 into xi. So already u1 taken as common, here remaining is minus 1. Sorry, minus 1 into xi minus xi. Again here also u1 term into eta is there. So already u1 taken as common and remaining term is eta. So here minus is there, minus eta. Again u4 term, sorry. Next again in this coefficient equation u1 term is positive. So here xi into eta is there. So 1 into xi eta. So this is the equation common term in u1. Next again u2 term. So here u2 term is taken as 1. Again in xi coefficient is here xi into u2. So u2 taken as common and remaining term is plus xi. Again eta term. So minus u2 into eta. So u2 is taken as common, here remaining is minus eta. Next here also u2 term. So minus xi into eta. Again u3 coefficient, u3 displacement equation, u3 1. Again here u3 term into xi 1 plus xi. Here u3 into xi, u3 taken as common and remaining term is plus eta, and u3 into xi eta. So plus xi eta. Next again u4 displacement equation 1. Next in this eta minus u4 into eta, u4 term already taken as common and remaining is minus xi. Again here also plus eta, again minus xi eta. So these are the common coefficient equation for by taking the common as displacements. So here u is equal to 1 by 4 into, this equation can be written as 1 minus xi into 1 minus eta, again into u1 plus 1 by 4 into 1 plus xi into 1 minus eta. This is the u2 term. Next 1 by 4 into 1 plus xi into 1 plus eta into u3 plus 1 by 4 into 1 minus xi into 1 plus eta. This is the u4 term. So here u is equal to, this all will taken as n1 and this total will be taken as n2. Here n3. This one is the n4. Okay. So from this we can get u is equal to, all will be taken as n1 into u1 plus this all taken as n2. So n2 into u2 plus again n3 into u3 plus n4 into u4. So this is the shape function equation. By deriving the coordinates, we have to substitute in this polynomial equation by deriving the shape function. So this is the final, we get the total shape function equation by we have to substituting in the polynomial coefficient equation. Similarly, for v is equal to n1 v1 plus n2 v2 plus n3 v3 plus n4 v4. This is the for y axis displacemental equation. This is the for x axis displacemental equation. So from this we get the shape function equations are n1 is equal to 1 by 4 into 1 minus xi into 1 minus eta. Again n2 is equal to 1 by 4 into 1 plus xi into 1 minus eta. n3 is equal to 1 by 4 into 1 plus xi into 1 plus eta. n4 is equal to 1 by 4 into 1 minus xi into 1 plus eta. These are the shape function equations we are using in problems. So now we have to write these two equations in matrix form. So how we write matrix form? So displacemental axis u and v. Okay. Here n1 u1 is there. So here n1 we are taking as matrix form. N1 U1 V1 N2 V2 N3 V3 N4 and V4. So we have to write these two equations in matrix form. These are the two displacemental equations U and V. Now we are writing these two equations in the matrix form. This equation U and V, these are in the matrix form. Again N1 U1. So N1 we are writing here N1 into U1. Okay. Next V term is there na here? No. So we are taking as 0. Again N2 U2. So N2 U2 means next N2 term. This is the U2. Next V2 y-axis term. So y-axis term any displacement is not there. So 0. Again plus N3 U3. So N3 U3. Again V3 term 0. Next again U4 term. U4 term is this one N4. So N4. Next again V4 term 0. This is the displacement of x-axis. Again displacement at y-axis. N1 V1. So N1 V1 is there, here U1 is there. So U1 is not there in this y-axis term. So we are taking as 0 here. Okay. Next N1 V1. N1 V1 means here we are taking as N1. Next U2 term. U2 term is not there here in y-axis term. So we are taking as 0. Next V2. V2 means here N2 V2 is there. So here we have to take N2. Next again U3 term. U3 term is not there in this y-axis equation. So you are taking as 0. Next V3 means N3. Similarly for again the N4 equation. So this is a matrix equation finally we are getting by deriving the shape function derivation. Finally we write this equation as U is equal to N into V. This is the N is the shape function displacemental equation. So finally we are getting the U is equal to N into V. V is the displacemental total matrix. U is equal to N into V. This is the shape function deriving from the 4 noded quadrilateral element. Thank you. Later we discuss the another topic in another section.